Hey guys, Avi here, and welcome back to the Codex. In today's video, we're going to be learning about Big O notation, one of the most complicated and hardest things you might face in a coding interview, but today I'm here to explain it to you in just 5 minutes. Let's get started. Now, what is Big O notation, guys? Well, the general definition is a measure of how well a computer algorithm scales as the amount of data involved increases. Now, there's a bunch of definitions out there. Some people say that Big O describes the execution time required or the space used by an algorithm. Other people just say Big O notation is a language we use for talking about how long an algorithm takes to run. At the end of the day, Big O tells you exactly that, how long an algorithm takes to run. Now, it's dependent on the size of your inputs. It depends on how much input you're actually passing in. Big O notation is used for inputs that get arbitrarily large. For sure, if you're using an array that's maybe 10, 20 numbers, it's not going to take that long to run. However, the bigger your array gets, the slower your algorithm gets. And the smaller your Big O notation is, the faster your algorithm will run. So what is Big O notation actually measured? There's 3 different cases: best case, average case, and worst case. Let's say we have an array, and we're looking at numbers, we're trying to find a specific number. Let's say we find it on our very first try. We got lucky. That is the best case. Average case is what will happen on average, depending on multiple different trials. But last but not least, the worst case is what Big O notation is all about. Big O specifically describes the worst case scenario of your algorithm, how bad your algorithm can truly run as the input gets arbitrarily large. So what are the different types of Big O's out there? Well, here is a Big O complexity chart provided by bigocheatsheet.com, and you can see how Big O truly functions. O of 1 basically means constant time. It's instantaneous. O of n means that it's dependent on the size of your array. O of n log n means it's the size of your array times log of that. O of n squared is the square of your data set. O of 2 to the power n is self-explanatory, and O of n factorial. As you can see, as these numbers slowly increase and become bigger and bigger, the operations become worse and worse, and at the end of the day, you can see how the smaller your Big O is, the better your algorithm is. It'll be able to handle more data faster, and that's all we want for algorithms, how fast your algorithm can run. So let's go ahead and take a look at some examples. O of 1, constant time. As you can see in these equations, x is equal to 10 plus 23 times 5, print x plus y, it doesn't matter how many additions or multiplications or subtraction signs you add, at the end of the day, the Big O of these equations, of these expressions, is going to be constant. It's instantaneous, and that's why we say O of 1. One big thing that you should note, guys, it doesn't matter how many O of 1s you have, if you multiply Big O by a constant, it will be O of 1. The next example is going to be linear time, O of n. O of n basically means that, hey, n is the number of items in the array, and it's dependent on how many items we have. For I in range 0, n, print I. Even though print I is O of 1, this entire statement is going to run n times based on whatever n is. That's why we can say that the Big O of this function is n times O of 1, which is O of n. Last but not least, let's look at quadratic time, O of n squared. For I in range 0, n, we're going to run that n times. For j in range 0, n, we're running that n times as well. Print I times j. Even though print I times j is O of 1, we're multiplying that by n and then n again. And that's why the Big O of this is O of n squared. That's what basically Big O tells you guys, how fast your algorithm is running and how useful it's going to be when you have large data sets. So just to recap, guys, let's take a look at some examples of code you might see. A print statement is going to be Big O of 1. Again, it's a simple print statement, O of 1. For I in range 0, n, print I. Again, you have O of 1 that's being run n times. It's dependent on the size of this sort of range. That's why it's O of n. And in this nested for loop, guys, we can see it's being run n times, and that's why we can say it's Big O of n squared. So to recap, guys, what is Big O? Big O is going to tell you how fast your algorithm runs. When you're creating algorithms in computer science, you want your algorithm to run as fast and as efficient as possible. If it takes a lot of time, if it's taking a lot of space, you know that algorithm is not for you. That's why it's always good to figure out the Big O of your algorithm beforehand. If you have a high Big O, you know that's not the right path you should be going down. The smaller your Big O is, the better it can handle larger sets of data, and the faster your algorithm will run. Thank you so much, guys. If you have any questions, let me know. Don't forget to like, share, and subscribe, and I will see you in the next video.